Alright guys, so we're into lesson 3.1, which is reviewing for test 1, which is on motion. So the first slide here is just kind of defining the different ideas, equations, for the basic concepts of distance, displacement, speed, velocity, and acceleration. So those are all there. So I don't need to read those to you because you are capable of doing that. I'm going to go to the next slide, which is the first one that deals with a velocity versus time graph. So you definitely have a velocity versus time graph on your assessment. So you want to make sure you can answer these questions and perform the different tasks of calculating acceleration and displacements from this type of graph. So let's go ahead and go through these answers and try to discuss what they are. So let me try to get this set up better. Okay, so for the first question here, it says what time is the object stops? So that happens when the velocity is equal to 0. That's what we look for when you're stopped. So it stopped at the points where velocity is 0, so I'm putting x's here, so it looks like at 8 through 10 seconds. And that, I would say, is the only time when it is stopped. So I would say 8 to 10. Yep. Sorry. Got sidetracked for a second. So 8 to 10 seconds is that answer. For moving in the positive direction, you have to look for where the velocity values are positive. So that is anytime we're above the 0 up here, we have a positive velocity. So all this time that I'm kind of tracing here, all the way from 0, it looks like, to 8 seconds. So this one's 0 to 8 for the time period. Negative is the opposite of that, so when you are down here in the negative section of the graph, as you can see, these values are negative. That's a negative velocity, which means you're moving left. So that is this part that I'm kind of doing a black line trace of. So that's from, it looks like, 10 to 20 seconds. Okay. On this graph, we are practicing, we're answering all the different questions, going to figure out the accelerations and displacements for all of these different time periods. But we just want to, on the test, you won't have to do every single one. It's not quite as intensive in terms of you repeating your steps over and over and over again. All right, so let me kind of just erase these lines because they can get confusing if I leave them there too long. So now we're going to look for anywhere where the velocity is increasing. So if you increase your velocity, that means the value or the number is getting larger. Just a reminder, positive and negative just mean direction. So don't misconstrue like negative as a smaller number than a positive number. So we're just looking at like the absolute value or the number. You can also think about the line and what the line does. And if you remember your speedometer, when you increase your velocity, you step on the gas, your gauge goes away from 0. So that's the way that I like to remember it or think about it. So away from 0 is what we're looking at. Let me shrink that down. So I would say the times where it moves away from 0. So I would say that's towards, not moving towards or away, towards, constant. This is away. So the first one, or maybe the only one, excuse me, that it looks like it speeds up is where I'm tracing in yellow there. So that highlighted section of the graph. So kind of continuing on with this typing. It's away from 0 for, it looks like 10 to 16 seconds. Okay. So that's the only time the actual line moves away from 0. And again, just to kind of reiterate this, so you can see that, yeah, it goes that way. I want to make that a little smaller, so it's going away from the 0. And then decreasing velocity would be the exact opposite, so that'd be moving towards 0. So the number values, and just going back to the, increasing, we start at 0, and then 2, 4, 6, 8, 10, so that's getting bigger. If I go to the decreasing, the number value gets smaller. Okay, so we want the numbers to get smaller. Again, don't think about negatives, bigger negatives is getting smaller. That's not actually what it's saying. It's just it's moving faster to the left. We want to go towards 0. And the times when that occurs, there are several. So let's highlight, again, the sections that we think are the ones that work. And I'll change the color. So I would say this is going towards 0, that is going towards 0, that's going towards 0, and finally this last section here is going towards 0. So to write those out, good. It looks like 0 to 2. I would say the next time is 4 to 6 and then 6 to 8, so I'm just going to say 4 to 8 for that whole section, even though it's 2 different slopes. Then the last one is 18 to 20 seconds, and these are all second intervals. So that is that one. And then finally moving with a constant velocity, that's just your horizontal lines, that's where your acceleration is equal to 0, so we can highlight that. In pink here, that pink section and that pink section. Oh, well, not that one. Let me refuse. That's stopped. So let me go back. That is stopped there. So your velocity is 0. So that's technically not moving. So those two sections in pink here, I'll make a T on them. Okay, those are the constant ones. So it looks like the answers for that one, last question, would be 2 to 4 seconds and 16 through 18 seconds. So that goes through those first set of questions that you'll have to answer similar kind of ideas. So it's important. You can come back and look at this and study and help you with that. All right. So the next part is to solve for the acceleration of each time period. So again, the acceleration is the slope of this graph on a velocity versus time graph. That's what the slope of v versus t graph is equal to the acceleration. So it's just the rise divided by the run. So the rise, in these, you're just going to measure how much it goes up or down, and then you're going to measure how much it goes over. So for this first section from 0 to 2 seconds, we'll try to keep this nice and neat here. So from 0 to 2 seconds, it looks like it goes from 16 to 10, so that's a drop of 6 meters per second, and we're going to divide that by 2 seconds of time, because that's how much time goes by. So that's going to get you a negative 3 meters per second, so, or meters per second squared if you want to write it that way. So that's this first section. I'm going to repeat this for each of these different times when the slope changes. So from 2 to 4 seconds, seconds here so we don't get confused. So from 2 to 4 seconds, it's just 0. It's a horizontal line, there is no slope. 4 to 6. From 4 to 6, it drops 2 meters per second, so it's a negative 2 meters per second, and we're dividing that by the 1 unit of time, which is 2 seconds. So that's going to be a negative 1 meter per second. From 6 to 8 is the next one. That's going to be a drop of 8 divided by 2. It's the same units over and over, so I'm just going to shorten that a little bit. So that's a negative 4 meters per second. 8 to 10 is another 0 section. 10 to, it looks like 16 is the next one. Got to be careful reading this one because it's like halfway between negative 14 and negative 15 meters per second, or negative 16 meters per second, so that's a negative 15. And we're dividing that by 6, so that's a little bit weirder, but it just gets you negative 2.5 meters per second. Again, if you look at these, all these lines so far have been either negative slopes or horizontal slopes. We're getting to a section where we will have one positive on this graph. So 16 to 18 seconds. So you want to make sure you have those positives and negatives. That's important. 16 to 18 is another 0 because it's horizontal. And then finally 18 to 20 seconds. It goes from 15 up to 5. So it's a gain of 10. Negative 15 to negative 5. So it's a gain of 10. And we're dividing that by 2. So that's going to be a positive 5 meters per second. So those are all the accelerations for all the different time intervals that we just calculated. The next one, it asks you to calculate the displacements. So calculate displacement for each of these time periods again. So we're gonna find the displacement. Remember the displacement, just kind of describing it. The displacement, or delta x, is equal to the area between the line, the velocity line. There we go. The velocity line and the time axis. So I'm going to draw that in to help you kind of visualize what I mean by that. Try and do this. There we go. And shrink it and then drag it. No, just shrink it. Okay. So the time axis here is this red line going across. So that's where we're going to stop. And I'm going to use the crayon to draw in the different shapes. So if I start at this first one and I make it red, I'm starting at the line, I'm going down until I hit the line, and that's for an entire section here. So we have those shapes put together, so we're going to find the area of this whole section here, and I would say there's like 2 parts of that section. We would continue to do that for the different parts here. So that from 2 to 4 would be in orange. Just switching up colors, it doesn't really matter what. That's going to be 4 to 6, so that one's another trickier one. That's a trapezoid. Then from 6 to 8, another triangle. 8 to 10, there is no area, so there's nothing to do there. Then from 10 to 16, we have a big triangle, so that's the shape we need there, that area. Then 16 to 18 is another rectangle here in brown. And again, you always start at kind of the line and stop at the horizontal axis. And the last section here is another one of those trapezoid shapes. So we're going to have to find the area of the triangle and the rectangle, so that triangle and that rectangle, and add them together. A couple other reminders. If you have a positive velocity, then you have a positive displacement. And I'm just going to say DISP for displacement. If you have a negative velocity, that means you have a negative displacement. So it makes sense that these are below the x-axis and these are above the x-axis. So I'm going to go ahead and work through these equations and try to type them out here. Whoops. And I'm going to try to make this larger and smaller and larger again. Okay. So for the first one, which is from 0 to 2 seconds, you got 2 sections, so it'd be 1/2. The base, I'm showing all the units for this one, the base is going to be 2 seconds, and the height is going to be since it's the triangle part, I'm only concerned from here going up to there. So that's from 10 to 16. So that's going to be a 6, a positive 6. So that's a positive 6 meters per second. Again, I'm showing all the units. You don't have to do that on your work. You just need the answers unit at the end. I'm also writing in positive and negative to make sure you realize it's a positive section. Okay, so that's the triangle part. The rectangle part is a rectangle that is 2 seconds wide, and it's got a positive 10 for 10 meters per second for its height. So if you half of 2, that's 1, and then 1 times 6 is going to be 6, and then 2 times 10 is 20, so you're going to get a total of positive 26 meters for the first one. For 2 to 4 seconds, this is an easier one. So it's just going to actually be 2 by 10, so I'm just going to copy this. Don't know why it's shrinking it so much. I'll type it up. So it's going to be 2 seconds by positive 10 meters per second. So that's just a positive 20 meters. So again, it gets kind of repetitive. The next one from 4 to 8 or 4 to 6 seconds. You got a couple regions again, so you get a triangle, so it's 1/2. The 2 seconds is the base, and it's a 2 meter per second high triangle there, and then plus the 2 by 8 rectangle. So half of 2 is 1, so it's going to be 2 plus 16, so that's 18 meters. Again, you could just put all this in your calculator. It's positive, so I'll just try to be consistent there. 6 to 8 seconds is another triangle, so it's 1/2. The base is 2, and the height is 8. So that's just going to get you positive 8 meters. 8 to 10 seconds is no area, so that's 0. Then 10 to 16 is the big blue triangle. So it's going to be 1/2. The base is 6 seconds. And then the height there is negative 15 meters per second. So half of 6 is 3. 3 times negative 15 is going to be a negative 45 meters. Then we have 16 to 18, which is just a rectangle. So that's going to be 2 by negative 15. Again, the negative is important here. You want to make sure you get those in there properly. And then finally the last section, 18 to 20 seconds, is 2 parts. So there's a triangle section. So this part here, this triangle, goes from 5 to negative 5 to negative 15. And that's again for 2 seconds. So that's going to be a negative 10 meters per second. And then you're going to add in the rectangle part, which is 2 by a negative 5. So that total there is a negative 20. So half of 2 is negative 10, and then 2 times negative 5 is another negative 10, so that's a negative 20. So those are all the displacement values for all those different sections. And hopefully you can follow along. I have this printed out in the notes, in the answers and the materials here too, so you can look there. Then, again, just more practice. I'm going to skip over this one because I don't want the video to be too long, and I've already answered these on the answers and the material, so you can go through that. And it's just the same thing that we just did. It's just another practice of velocity versus time. So I'm going to jump ahead to the 2 problems that are similar to 2 problems that you'll have on your assessment again. So the first one, a car starts at 30 meters per second, slows down to 15 meters per second in 25 seconds of time. You're supposed to calculate the car's acceleration and how far does it move. So again, we're going to go through the whole process that we typically do when we're solving kinematics types problems. And the first one is to draw a picture. So we need to draw a car. Okay, so that's the car. And the car is moving, so it's got an arrow, and it says it slows down, so to slow it down, I'm going to make the arrows get smaller. Okay, so there you go. That's a good enough picture. We've discussed, a general idea. We've displayed that we understand how this car is behaving. So next we fill in our table with the chart, so delta x, vi, vf, a, and delta t. So that's there. And what we're going to do is we're going to take this information that is given, all the numbers, and try to put them in the chart. So it starts at 30 meters per second. Meters per second is a measurement of velocity, and this is the starting one, so it's the initial. So that's 30. again, it's implied that it's positive. You don't have to write it out. It slows down to 15 meters per second, so 15 meters per second is going to be the final. It might not be the exact final, but it means it later. And then 25 seconds, that's our time. So we're going to use those 3 givens out of the 5, which is what you need. So as soon as you get 3 out of 5, you're good. And we're going to solve for the acceleration. So I'm going to put my question mark here, and my my box that is not involved, or the thing that I don't care about, is delta x, or the displacement. That's actually part B, so I'll put a little b and a question mark there, and this was A. Okay. So what I'm going to do, let me pause real quick, and then I'll pull up a slide with the equations, and you'll be able to tell which one it is. All right, so I imported the equations, so we're picking from these 4 equations, and you got to figure out which one doesn't have delta x. So as you go across, this is the horizontal one, and then these are the vertical ones for free fall and the constant for gravity. This one does not have delta x, so we're going to use that first one. So let me try to take a quick snip of that. Alright, so we're going to use that equation, and we're going to plug into that. So part A, and let me type a little bit here. So plugging in the numbers, the final velocity was 15, the initial velocity was 30, plus the acceleration, which is what we're looking for, and then we have 25. So again, be careful with solving here. We're going to subtract 30 to the other side, so if we subtract 30, I'm going to try to show the work on both sides. We will get negative 15 equals 25a, and then you have to divide by 25, and a would be equal to negative 15 divided by 25. 14 and 15 divided by 25, and that is going to get you negative 0.6 meters per second squared, or meters per second. It's easier to type meters per second, but you can definitely write meters per second squared. So that is the acceleration that we have in part A. Now that we have the acceleration filled in, we are going to solve for the displacement. So we're going to come back over here and pick whatever equation we think is the best one. Since we have 4 out of the 5, which of these do you think is best to solve for delta x? It's not the first one because there's no x there. So these 3, I would pick the last one probably for me, if I had my preference. So let me snip that one, since I'm the one doing the problem here. And I'm going to put this over here again, and move it. And I'm going to start typing in my values. So if I had the displacement, that's what I'm looking for. So I'm just going to leave that as x. I'll want to write in the delta. 1/2. VI is 30. VF was 15. And then we have a time of 25. So really it's just putting that expression in your calculator and finding a value for it. So that is equal to 562.5 meters if you put that in your calculator, and that's your displacement, which I'll just write as delta x. So there's the solution for problem number 1. For problem number 2, I'm going to do that on another slide because I ran out of space here. This one. So, moving this up so we can draw. Now we're doing a free fall problem. It's the same idea, so we're just going to kind of move things vertically. So we have a ball. The ball's pretty easy to draw, so it's a dot. Okay. And it says we're going to drop the ball from a height of 6 meters. Above the ground. What's the ball's final velocity? It's assuming right before it hits the ground. And then how long does it take for the ball to hit the ground? So those are the questions. So if I do this, the ball is going to drop, and then it's going to move downward. As it moves downward, it's going to pick up speed. And maybe I'll draw a couple arrows. So there it's going faster, and I've signified that by the arrows getting bigger. So that's a good enough picture. Getting credit for that. For the table, set up the 5 variables that are in free fall. So displacement, which is change in y, initial velocity vi, final velocity vf, or velocity later on. Instead of having a, we have the gravity equation and then delta t. So those are the ones that we're going to use, and we just go through and figure out what's what. All right. So first word that's important is dropped. So if you're dropping it, you're not throwing it up, you're not throwing it down. So your initial velocity is 0. So 0 meters per second is your vi. Gravity is negative 9.8. I know that because I know I'm on Earth. It doesn't specify otherwise, so we just make the assumption we're on Earth, so that's meters per second squared. And then 6 meters is the one that sometimes gives people trouble, and let me kind of explain why this happens. So 6 meters, most people figure like, oh, that's how far it's above the ground. But we're trying to find the displacement. So displacement is the change in position, so it starts up here and it moves downward. So a lot of people just write 6 meters. And that is not 100% right. So this is a positive value. So if somehow you dropped it and it went up 6 meters, I would say that is not what happens physically. So you got to write negative in front. And if you don't write that negative, you're going to get some weird answers. And it's going to come up with things where like time is negative or your velocity final is positive. So like again, it's not, if it doesn't make sense, go back and look and see what you could have messed up the sign on. This is probably the only one, because if you drop something, there is no sign on 0, and gravity is always negative because gravity is pulling down. So this is the thing that you may have made a mistake on. So again, make sure it makes physical sense when you think through it. All right, so we need to go back to our equations, and based on these 3 givens, we're trying to solve for the ball's final velocity. So for part A, we're going to do that. And so for this first one, time is the variable that is not given. If we want to do part B actually asks for that time. So we could do part B first. There's nothing that says you have to do it in the order that's given. Either way should work. So I'm going to use the equation though. I'm going to do it the way it's given, and I'm going to solve for the equation without time. So coming back to this slide, I want to select out of the second row equations, which is our free fall ones. I want them without time, and that is this equation. Okay, so I have that equation now for part A. I'm going to shrink it a little bit because it's a little obnoxiously big. And then I'm going to start typing. So for the first one, the final velocity is what I'm looking for. So it's going to be VF squared. I'm just going to put that notation for squared. DI would be 0 squared. And then plus, and then 2 times G, which is negative 9.8. Make sure you put in the negative. And then delta Y, which is negative 6. And this is our first kind of time where you would run into a math problem if you tried to do this without the negative here. So, so you're going to plug that into your calculator. So 0 squared is just 0, so you don't have to worry about that. That's just nothing. It goes to 0, so you get VF squared equals 2 times negative 9.8 times negative 6. When you do negative times a negative, you get a positive value, and then you can take the square root when you solve for VF. For the second, or if you put in a positive 6 here, you'd have a square root of a negative number, which wouldn't make any sense, so be careful with that. So let me go ahead and keep going. So VF squared is equal to 117.6. And then you got to take a square root. So you'll look for the key that is the square root key on your calculator, something like that. And you'll get VF is equal to a value of 10.8 velocities meters per second. Now, I want you to think about that and decide if you think that is a reasonable answer. And the thing I want you to think about is the direction. So this is a positive value, so somehow at the end of its motion it's moving up, and that doesn't make sense. So going back to your math classes, reviewing them, remember in math you can either get positive or negative for the answer to a square root problem. Your calculator will always tell you it's positive, but you have to decide if the negative answer makes more sense than the positive, and it does. And the reason why it does is the ball is moving down. So it should be negative 10.8 meters per second for that answer. Okay. So at this point, you have the answer to part A. It seems to make sense. It's moving down. We're going to go back and try to figure out now which equation we're going to use to solve for time. And again, you just go back to your equations and you figure out which one of these looks easiest to solve for time. You can use any of them. So this one's okay, this one's okay, this one's okay. You can't use the one we did because it didn't have time. So the one that I'm going to use is this first one. And let me just take a capture of it again. Alright, so there's that formula. And plugging into that formula isn't very different than what we've done in the past. But again, if you didn't get the right answer, there we go, that's better. If you didn't get the right answer before, and you put negative 10.8, if you didn't put negative 10.8, you would get an incorrect answer for your next step. So be careful with those signs. The initial velocity was 0, so that's going to be 0 there. Gravity is negative 9.8. And then we are looking for time. So I'll draw in the triangle here. So 0 is just 0, we can ignore it. If you made this positive and you try to divide by negative 9.8, you get a negative number for time. You can't have negative time. We're going to divide through by gravity on both sides. So divide through by negative 9.8, divide through by negative 9.8. And delta t, once you do that, turns out to be 1.1 seconds. Okay, so that is the review that you guys have going on for your test. Good luck on your test. Again, refer back to your notes and the videos and make sure you're prepared for it. And if you have any questions about what I'm asking in a question or something like that, you can feel free to message me on D2L or send me an email. All right, have a good one. Be well.